Yes, welcome to this video. So already on unit number 2, we have completed 3 videos. Now this is the 4th video. So in this video, I will explain how to solve a homogeneous linear PD with constant coefficients. The right hand side function is a polynomial in x and y. Okay, so let us explain on the whiteboard. Yes. So in this one, method of solving PDEs of the form partial differential equations of the form some function of d and d dash operating on z yielding some function of x and y, say some x power m into y power in general, or a combination of various terms of this form. Okay, containing product of one power of x and power of an algebraic function of x and y simply, or simply an algebraic polynomial in x and y, an algebraic polynomial in x and y. So the method is, as usual, the step 1 contains complementary functions. So find complementary function as usual. That is step 1. Already you know how to find complementary function. So let us not waste much time on this. Now find the particular integral. As usual, particular integral means 1 by the LHS operator to be operated on right hand side. Here what we'll do is, in the denominator, we will take out the maximum power of d as common. Means, so take this as 1 by d square into some function of d by d dash, or d dash by d, like this we'll get, of x power m into y power n. If f of d dash is a second degree polynomial, in d and d dash. Or if it is a third degree polynomial, then take out d cube as common, leaving some function of d dash by d. If our f of d dash is a third degree polynomial in d and d dash. So depending on the maximum power of d, if the maximum power of d is d square, then we'll take d square as common. If the maximum power of d is d cube, we'll take d cube as common, like that, and so on. And then what we'll do is we'll apply using binomial theorem. So using binomial theorem, simplify. So only by doing one problem we can understand this procedure. So I'm not wasting much time in explaining this procedure here. Just I'm writing the steps only. While doing problem, you can understand the actual process. And the last step is, as usual, the complete solution is z equal to CF plus PI. So in this, we need the concept of binomial theorem. So binomial theorem is very important. So we'll use that. So we'll use the following formulas. Formulas that are useful in binomial theorem. 1 plus d power minus 1 is 1 minus d plus d square minus d cube plus d power 4, like this. And 1 minus d power minus 1 is 1 plus d square plus d cube plus d power 4, etc. So formulas on binomial theorem which are useful for our discussion. We'll use either of these two formulas in our all the problems. Okay. So directly we'll go to problem to understand the concept very easily. So let us take the problem. Solve. Yes. Yes. Solve dou square z by dou x square plus 2 into dou square z by dou x dou y plus dou square z by dou y square equal to x square plus xy plus y square. Generally, in the examination, you will get only second order homogeneous linear PDEs. So let us concentrate mainly on second order. In the previous 3 videos also, I have considered problems of third order also, but you focus mainly on second order. Once you are comfortable with second order, then you can easily go for third order problems also. That is not an issue. So, give in the standard notation, given PDE is same as d square of z plus 2 into d dash of z plus d dash square of z equal to x square plus xy plus y square. This is the problem in the standard notation. Now, directly go to step number 1. In step number 1, first we'll write the auxiliary equation. And the method of writing the auxiliary equation is simply replace d with m and d dash with 1. So d square becomes m square. 2 into d dash, 2 into m into 1, 2m plus d dash square 1 square equal to 0. So this is nothing but m plus 1 whole square equal to 0, which becomes m equal to minus 1 comma minus 1. So roots are same, m1, m2 are same. So as per the procedure, the complementary function when m1, m2 are same is some function of y plus m1x plus x into another function of same y plus m1x. Actually, we should get f2 of y plus m2x, but when m1 and m2 are equal, then in place of m2, we'll write m1 and we'll multiply outside with x. So in this case, both m1 and m2 are minus 1. So f1 of y minus x plus x into f2 of y minus x. This is the complementary function. So complementary function needs only the LHS operator. Now, for the second step, for particular integral, we need the inverse operator. We have to apply the inverse operator of LHS on the right-hand side function. So that is our second step, particular integral. So the particular integral is 1 by the LHS operator. LHS operator is, see, once again, what is LHS operator? D square plus 2d d dash plus d dash square. 1 by d square plus 2d d dash plus d dash square. This is to be operated on the right hand side function x square plus xy plus y square. Now, so the process already we discussed. The process is we have to take out the maximum power of d is common. In the first term we have d power 2. In the second term we have d power 3. In the third term we have no d. Okay. So we can take d square as common. So after taking d square as common, what we'll get? So 1 by, after taking out d square as common, first term becomes 1. Second term becomes 2d d dash by d square. Third term becomes d dash square by d square. To be operated on x square plus xy plus y square. Now, so this is same as 1 by d square of, so 1 by 1 plus 2 into d by d square becomes 1 by d. So 2 into d dash by d. Here d dash square by d square means d dash, we can keep it as it is because nothing is cancelled here. Of x square plus xy plus y square. Now here we have 3 terms. Consider 1 as first term and remaining 2 as second term. We can go for binomial theorem. How? See, send this binomial to the numerator as it is. 1 is the first term and 2d dash by d plus d dash square by d square as second term. Send this to the numerator with power minus 1. X square plus xy plus y square. So it is the forms of 1 plus x power minus 1 or 1 plus d power minus 1 in that form. And already I have given the formula of binomial theorem. 1 plus d power minus 1 is 1 minus d plus d square minus d cube plus d power 4. In place of d, if you have any other function of d or d dash, then just in place of d, replace that. So we'll use this concept now. So for the timing, if we consider this as some phi of d, then 1 plus d power minus 1 minus this 2d dash by d plus d dash square by d square plus square of this 2d dash by d plus d dash square by d square and so on to be operated on x square plus xy plus y square. Okay, we are treating this as some x. 1 plus x power minus 1 minus x plus x square. We are using that formula, binomial theorem formula. Now what we do is, in the numerator we have only d dash or d dash square. D dash means partial derivative with respect to y, dou by dou y. Okay, so in this function, observe the maximum power of y. What is the maximum power of y? 2. In first term there is no y. In second term y power 1. In third term y power 2. So maximum power of y is 2. So for y square, the first derivative with respect to y is 2y. Second derivative is 2. Third derivative will be 0. So we need not consider terms of d dash with power 3. Power 3 means third derivative of that function with respect to y. Since the third derivative of y square becomes 0, we need to consider only up to square. So what we'll do is 1 minus 2d dash by d minus of plus minus d dash square by d square plus, here use a plus b whole square, a square 4 into d dash square by d square plus 2ab 2 into 2d dash by d into d dash square by d dash square. So 2 into 2 4 d dash cube by d cube plus b square d dash power 4 by d power 4 and so on to be operated on x square plus xy plus y square. As we already observed, so the maximum power of y is to consider terms up to d dash square only. We can ignore this d dash cube term, d dash power 4 term and all higher power terms. And d dash power 2, d dash power 1 and constant terms only. So we will consider only these 4 terms. That's it. Remaining can be neglected. So we will get 1 by d of d or d square. So 1 by d square of 1 by, just wait, not sir. There what you are taking common d square. So 1 by d square here, not d. Okay. So 1 by d square of 1 by d square of first term is 1, second term is minus 2 d dash by d. So 1 minus 2 d dash by d. Next, third term minus d dash square d square plus 4 d dash by d square. 4 minus 1 is plus 3. Plus 3 times d dash square by d square plus 4 times d dash square by d square to be operated on x square plus xy plus y square. Okay. Remaining terms can be neglected. Now, so 1 when operated on x square plus xy plus y square gives x square plus xy plus y square minus 2 by d into d dash of, d dash means dou by dou y of x square plus xy plus y square plus 4 by d square into d dash square means second derivative with respect to y, dou square by dou y square to be operated on this x square plus xy plus y square. So 1 by d square of x square plus xy plus y square minus 2 by d into dou by dou y. Partial derivative of x square with respect to y is 0. Partial derivative of x with respect to y is x. Partial derivative of y square with respect to x with respect to y is 2y. Plus 4 by d square into second order derivative with respect to y. Derivative of x square with respect to y is 0. Derivative of x square with respect to y. First derivative is x, second derivative is 0. Y square, first derivative with respect to y 2y, second derivative 2. So 1 by d square of x square plus xy plus y square minus 2 into 1 by d stands for integral with respect to x. So integral of x plus 2y with respect to x partially by treating y as constant plus 4 times 1 by d square means double integral of 2. 4 into 2, 8. So 4 times double integral of 2 with respect to x. Okay, by treating y as constant. 1 by d means integral with respect to x. So here y will be taken as constant. Please remember that. Here also y is constant. Now, so 1 by d square of, so 1 by d square of x square plus xy plus y square plus minus 2 into integral of x plus 2 with respect to x. Integral of x square by 2, integral of 2y into x. Because y constant is 2y constant, integral of 1 dx x. So this is minus 2 into yes integral of x dx x square by 2. Next 2y into integral of 1 dx x, 2xy. So plus 2xy. Next 4 into 2, 8. We have to integrate 2 times. So 4 into 2, 8 into integral of 1 dx is x. Again integral with respect to x. So 1 by d square of x square plus xy plus y square minus x square minus 4xy plus 8 into integral of x is x square by 2. And see what happens now. The x square will be cancelled. So we got 1 by d square of xy plus y square minus 4xy 8x square by 2 4x square. So here 4x square, here y square, here xy minus 4xy minus 3xy. So in the numerator now there is no d or d dash. Now in the denominator d square is there. Again, we know that 1 by d stands for integral with respect to x by treating y as constant. The same form we are using once again. So 1 by d square means 1 by d of 4x square plus y square minus 3xy. So for this 1 by d, we'll write integral. Integral of 4x square plus y square minus 3xy with respect to x by treating y as constant. So 1 by d of integral of 4x square with respect to x. 4 into integral of x square x cubed by 3 plus y square constant integral 1 dx x minus 3y constant integral of x square by 2. Okay. Now again 1 by d. 1 by d stands for again integral. Integral of 4x cubed by 3 plus y square x minus 3y x square by 2. 1 by d means integration with respect to x when y is constant again. So 4 by 3 into integral of x cube x power 4 by 4 plus y square constant integral of x square by 2 plus here minus 3x square by 2 constant, so 3y by 2 constant, sorry, minus 3y by 2 constant, integral of x square is x cubed by 3. So finally what we got here, 4 got cancelled, so we got x power 4 by 3 here plus x square y square by 2, and here 3 got cancelled, minus x cubed by. So x power 4 by 3 plus x square y square by 2 minus x cube y by, or after taking out 6 as common, we can write 1 by 6 into like that. So in step 1, we have calculated the complementary function f1 of I minus x plus x into f2 of I minus x, and in step 2, we have calculated particular integral. So by combining these two, we can declare the general solution. That is step number 3. So the complete solution is z equal to CF plus EI. So z equal to CF. F1 of I minus x plus x into f2 of I minus x plus this complementary for this particular integral. X power 4 by 3. X power 4 by 3. That's the first term. Second term, x square y square by 2 plus x square y square by 2, and the third term is minus x cube y by minus x cube y by. So this is the complete solution. Okay. Here there is an alternative method also here for simplification. See, here we have taken d square as common. Instead of that, we can consider this as d plus d dash whole square. D plus d dash whole square. Then also we will get a binomial, and by sending the binomial that we can also do. So let us not confuse by discussing another method for the same problem. Okay. So this is one problem. Now just we'll do one more problem and then we'll stop this video. So solve d square plus 3d d dash plus 2 dash square operating on z yielding 24xy. Because on any model, unless you practice two problems, you cannot get the actual input that's required. Yes, step number 1. The auxiliary equation is m square plus 3 into m into 1 plus 2 into 1 square equal to 0, which on simplification gives m plus 1 into m plus 2 equal to 0. That is m equal to minus 1, minus 2. So m1, m2 are different. So our component function is some function of y plus m1x plus another function of y plus m2x. Here m1 is minus 1, m2 is minus 2. So step 1 is as usual, there is no confusion at all in this. The partial integral means 1 by the LHS operator to be operated on this 24xy. So as usual, the maximum power of d is d square. Here directly we can take out d square as common, or we can do one more thing also. They can express the product and we can do partial fractions, and then we can get two different simple terms. We'll do that model for this problem so that you can understand. So we can factorize this as d plus d dash into d plus 2d dash. Okay. 1 by d plus d dash into d plus 2d dash by taking inspiration from this. If you replace d with m with d and 1 with d dash, then d plus d dash plus d plus 2d dash. You'll get the fact. Just multiply these two, check whether correct or not. You'll get very easily. Now find the partial fractions of this. What is the difference of these two factors? Simply d dash. So we can find the partial fractions and then we can simplify. Or if you don't like this partial fraction method, then as usual, we can go with our usual procedure. The annual problem ledu. So we'll go with the usual procedure. Let us not go with the new method. So we'll take d square as common. Maximum power of d is d square. So in place of d square, we'll get 1. In place of 3d d dash, we'll get 3d d dash by d dash square by d square. In place of 2d dash square, you will get 2d dash square by d square. This is to be operated on 24xy. Okay. So keep this d square the denominator and send this binomial. 1 plus 3d d dash by d square plus 2d dash square by d square to the numerator. 1 plus 3d d dash by d square plus 2d dash square by d square to the numerator with power minus 1, and then apply on 24xy. Here d can be cancelled, so 3d dash by d. Here 2d dash square by d square of minus 1, power minus 1. Again, it is of the form 1 plus x power minus 1. By binomial theorem, 1 plus x power minus 1 is 1 minus x. 1 minus this plus x square means 3d dash by d plus 2d dash square by d square whole square and so on. So we have used this formula. 1 plus x power minus 1 equal to 1 minus x plus x square minus x cube and so on. I use this formula. Okay. So 1 by d square of. Now, what is the maximum power of y? 1. So in the numerator, in this, consider terms up to d dash, not d dash square also not required. Up to d dash only we need. So 1 minus 3 d dash by d. Here we have d dash square. This term is not required. Here, if you apply a plus b whole square formula, then we will get d dash square term, d dash per 4 term, d dash into d dash square, d dash cube term. So all are not required. Simply neglect all of them. Maximum power of y is 1. So we need up to d dash, not d dash square. Neglect all terms from d dash square. So 1 by d square of 1 of 24xy is 24xy plus minus 3 by d into d dash means dou by dou y of 24xy. Okay. So 1 by d square of 24xy minus 3 by d of partial derivative of 24x with respect to y. 24x constant, derivative of y, 1. Close. So 1 by d square of 24xy, 3, 24 is constant. So 72 by d of x. Now, we know that 1 by d means integral with respect to x by treating y as constant. So this is same as 1 by d square of 24xy minus 72 into 1 by d stands for integral. Integral x dx while treating y as constant. 72 into 1 by d integral of x. So 1 by d square of 24xy minus 72 into integral of x is x square by 2. So 1 by d square of 24xy minus 72 by 2, 36 x square. Now 1 by d square means 1 by d of this. Okay. And we know that 1 by d means integral with respect to x. So first keep this first 1 by d. In place of second 1 by d, write integral. So integral of 24xy minus 36 x square with respect to x when y is constant. D means partial derivative with respect to x. So 1 by d means partial integration with respect to x. That's why we treat y as constant. So 1 by d of 24xy. Here 24 constant, y constant. So 24y into, we have to integrate only x in the first term. Integral of x dx. The second term 36 is a constant. We have to integrate only x square. Integral of x square dx. So 1 by d of 24y into integral of x square by 2 minus 36 into integral of x square x cube by 3. So we got 1 by d of 24y by 2 is 12y. So 12y into x square minus 36 by 10 again 12. 12 of x cube. Now again 1 by d is there. 1 by d stands for again integral. Integral of 12y x square minus 12x cube with respect to x. Since 1 by d is a partial integration with respect to x, we have to treat y as constant. So the first integral 12y will come out. We have to find only integral of x square. The second one 12 is a constant. We have to find integral of x cube. So 12y into integral of x square x cube by 3 minus 12 into integral of x cube x power 4 by 4. Now 12 by 3 is 4. So 4 times yx cube or x cube by 12 by 4, 3. 3 times x power 4. So this is the particular integral. So the first step, the complementary function was found to be f1 of 5 minus x plus f2 of 5 minus 2x. Okay. And in this second step, we got the particular integral as 4x cube y minus 3x power 4. Now, we'll declare the final step. That is the complete solution. The complete solution CS is z equal to CF plus EI. So, z equal to CF What is our CF? F1 of y minus x plus F2 of y minus 2x. So F1 of y minus x plus F2 of y minus 2x plus this PI, particular integral, 4x cube y minus 3x power 4. 4x cube y minus 3x power 4. So this is the complete solution where this F1 and F2 are constants or sorry, arbitrary functions. The complete solution may contain arbitrary constants or arbitrary functions which are equal in number to the number of. Okay, so this is the complete solution. Okay, so in this video we have discussed the concept of how to solve a partial differential equation with constant quotients of the form f of d dash of z equal to some polynomial in x and y. So this is our fourth video. In video number 1, we have considered PDEs of the form f of d dash of z when right hand side is 0. In the second video, we have considered PDEs of the form f of d dash of z equal to e power ax plus by. In video number 3, we have considered PDEs of the form f of d dash of z equal to sin ax plus by or cos ax plus by. And in this fourth video, we have discussed the method of solving f of d dash of z equal to x power m into y power n. So either a single term or combination of various terms of this form. That means algebraic polynomial extent. Okay. The next video will consider the general method when the right hand side is any other function other than 0, exponential, sin ax plus by, cos x plus by, or x power by power. Other than this 4, if we get any other function as log x plus log of from ax plus by or root of x plus by, any other function will be covered in the model number 5 that we'll discuss in the next video. Okay.